So today we're going to be analyzing the specimen for 2005 chemistry practical. That's SWOT analysis or qualitative analysis. I want you to just pay attention as we go through this together. So if you have any question you want to ask us, you can also leave it in the comment section. I will always attend to your questions. So the question we have here, I'm going to analyze it. At the end of this analysis, I will give you the name of the two compounds, because at this time, what we are doing here, what they want students to analyze a mixture of two salts. The two compounds, one is organic and the other one is inorganic. So mixing it together, we are going to analyze to find out the ions that are present in them, and that's the test that I believe that we're going to be working with in order to identify this thing. Remember, like in the previous video I made the other time, even though I did not really disclose this very thing, I was trying to help students to really know how to identify some of the cations. Although I received some comments and some people on my Facebook page, they were like, what's the kind of things you're doing? What does this thing mean? They didn't even disclose anything to us. So the major reason of that, I'm trying to let people know, my audience understand that there are basic tests or predetermined tests for each of these things we do. You understand? So those predetermined tests is exactly what will help you to understand what is really what you really have from your observation. They have a specific observation that help you to know all these things. So just like I said in that video, that when you add silver nitrate in a solution, and you have a precipitate which is insoluble when dilute nitrified acid is added, means that what you have is chloride ion. That is just a case of what you're going to be seeing here today. And again, and this chloride ion, this white precipitate, when you add aqueous ammonia to it, is soluble. That's the confirmed predetermined test for what? Chloride ion. So we're going to be taking this one after the other, and then we're going to see what we're going to find. Now, the first thing we have here is, like I said in that place, this is solubility test they are doing here. The solubility test is that the C plus water there. What we have there is soluble compound, already I wish I didn't do it before now. It's very soluble, and it gives us what we have a blue solution, as you can see here. So what I'm going to do now is to divide it into 4 portions, because we are going to be carrying different tests on it, different predetermined tests to help us understand the ions and cations that are present. So I'm dividing them into 4 portions. All right, just have to really need to get this thing right at the first time. All right, now I have all the portions. These are all the portions, they are all here. So I'm going to be taking it one after the other based on what I have there. This one says the first portion adds dilute sodium hydroxide in drops, then and in excess. Now, from what we have already is soluble. What we have is soluble. Here we have soluble and what? Blue solution. Blue solution. So when you have colors, remember colored substance, colored ions, presence of colored ions, most colored ions are what? As a result of what transition ions. So because it's color, that means what we are likely to see here is, you can say soluble salts, and then we have a transition ions, and then another thing there, we know that because I'm sure that they will give you the kind of salt you have, which is organic and what inorganic compound must be stated clearly, so that because we have an organic compound that is soluble, which means it's likely to be, since it's soluble, it must be ion that contains hydroxide, hydroxide ion, and it can also be can also be that one likely present. Move the other way. So remember OH group. I think this that's how they represent it. Now in the OH group, these are the organic compound that is always soluble. We have the OH, that is alkanol group. We have a alkanoic acid. We also have that is carbohydrate, sugar. That has to do with sugar. All of them are what? Soluble in what? In water, because we have a soluble compound. So now we continue. The next thing we're going to, okay, we're going to over to this one. So the next one we have which is the first portion. The fourth portion now, we're going to be adding sodium hydroxide in drops and in excess. Let me get sodium hydroxide. This thing cannot get there. So our first portion, we add sodium hydroxide in drops. Now we have gelatinous precipitate. We have gelatinous precipitate. You can see. Let's see what we have in excess. We have insoluble. It's insoluble in excess. Gelatinous precipitate is insoluble in excess. That means what we have is likely to be, if we have gelatinous precipitate, blue gelatinous precipitate, which is insoluble in excess, what we have here will be, it will mean it's likely to be, to have a blue or pale blue. Let's say blue, maybe let me use that. Pale blue, gelatinous precipitate, insoluble in excess, insoluble in excess. That gives us what we have here is, since it's pale blue, it means that copper 2 ion, likely present, That is what we have. So because we have this is one of those predetermined tests for copper ion. So we have what copper likely present. Let's go to the second portion. The second portion of this. To the second portion, we add, the second portion says you add, in the second portion you add aqueous ammonia. You add it what? In drops, then in excess. Where is the aqueous ammonia? Now, aqueous ammonia in drops. Now we have another, you can see the pale blue gelatinous precipitate again. And then there's something I want to explain here. You notice that we have a kind of three layers: deep blue color, pale blue color, and the region that's more like what we have originally. That means the region that has not been touched by what the aqueous ammonia. The region that has pale blue color is a area that has a few drops of what aqueous ammonia, and the region that has dark blue, deep blue solution is the area of excess solution. So just pay attention to it. It's very important you know this. Now I'm checking it. Notice that you can see that it seems that they are mixing up together now. Everything is like coming to give us pale blue gelatinous precipitate. This is something you should also note about this. So now we're going to be adding in excess. We know that it's insoluble. Let's add in excess and see what we have. So by adding in excess, notice that we have a deep blue solution. Let's okay. You can see that it's deep blue coloration. That gives us what? This is peculiar. This is peculiar test for what? This is a peculiar test for this is pale blue gelatinous precipitate soluble to give deep blue solution. So in our inference, what we can infer here is that copper 2 ion confirmed. That is copper 2 ion is confirmed in this case. Copper 2 ion is confirmed here. So the next one we're going to do is to the third portion, add dilute sodium hydroxide, then heat gently. This is another one we're going to be doing. Now, let's see what we're going to have here. Let's see, let me put on the light. Now to the next, to the third portion, I'm going to be adding dilute sodium hydroxide. Now it's added. Then I'm going to heat gently. I'm going to heat it gently to see what I'm likely to get. So we see that the color is changing. Now look at what we have. This is a reddish brown precipitate. Reddish brown precipitate when the third portion is added. When dilute sodium hydroxide is added to the third portion, we have reddish brown precipitate. So what does it tell us? What is it telling us now? So what does this mean? Let's look at it. So by having our observation is that we have reddish brown precipitate, um, so we have reddish brown precipitates. This reddish brown precipitate is telling us that something has happened. So reddish brown precipitate is as a result of what? Copper. That should be copper 1. It's as a result of copper 1. Copper 2 is now reduced to what? Copper 1 oxide. So what it simply means here is that since it's like that, it means that reddish brown plate means that copper 2 to what? Copper 1, meaning that reducing sugar likely present. Reducing sugar likely what? Present. Likely present, that is what it simply means, because since we know that it's a mixture of two compounds, one organic and one inorganic, and over here we notice that the organic one is present, is soluble, meaning that if you look at what we have, you have acid, you have ethanol, and then we have um, sugar or starch here all together, meaning that whatever must have happened might be as a result of what that very organic compound which is insoluble, and there's no other organic compound that can be soluble, that can have such effect with copper ion except reducing sugar. So now let's continue. Going to finish up. Now we're going to be testing. The next test will then be testing for what we are suspecting here. We're going to be testing for what we are suspecting here. So that you not say two inorganic compound. Then we would have been looking at maybe something like any other inorganic compound that they're reducing agent. But this time we were told that it was inorganic compound. So that is why reducing sugar is likely to be what we are expecting. So in this other one, the last one, we have the equation said. What we're going to be doing here is that solution portion. The third, how many portions do we have? We have about 1, 2, 3. The fourth portion. So the fourth portion, add Fehling A and what? B. Then heat gently. Then heat gently. That is what we are going to do now, because now we have found something that looks like a reducing sugar. We need to test for reducing sugar, which is likely to be our last test. For that. It's likely to be our last test. The test now is for the reducing sugar. Let's look at what we have. Then in our last portion, we take a portion of this. Oh, how am I going to do it? I'm going to do this now. Okay. I'm not doing it for the first time. This is the first time of my opening this thing. So I add this is Okay, let me start with Fehling. Fehling. Hey, let me start with this one. So we are going to heat them again. So this part is not. But I don't know why the change is taking too much time, but you can see that under this, we have already our reddish brown coloration there. I don't know why it's taking too much time, unlike what happened when the sodium hydroxide was mixed and heated. But in order to not to waste too much time, I think this is enough evidence that what we have here is what we have is reducing sugar by having this coloration down here. I'll try to add more of it. Maybe I was thinking that maybe I will not add too much. So, but you can see that the color here already is reddish brown already. We're getting to red brownish color, giving us a kind of red brownish color. Let me see. Yeah. You can see the brownish color is underneath there, the brownish color, telling us what we have here now. What it simply means is that we have, is a confirmation that we have, the confirmation that we have, what we have here is brownish, reddish, brown, precipitate, precipitate. So what is telling us here is that what we have reducing sugar, reducing sugar confirmed confirm, or you can also say glucose. Confirm, because glucose is the commonest reducing sugar that is readily available. So this is what we have, and actually, like I said, I'm going to be showing you this at the end of this class. For getting to this point, what we have here, the mixture of the salt is a mixture of C. C is a mixture of. I almost missed this last test, so I want to add it up to what I've done so far. I almost missed it. There's another test that you should be expecting, which I'm going to show you now. Remember, like I told you earlier on in the other half, we have what we have there is copper sulphate plus glucose, which I've already told you in the last video, which I'm going to measure up here in a ratio of 1:1. Now, another ion that should be tested there, it should be anion, which is what I'm going to do now to show you how to do that test. I almost skipped this very test. Now I have a portion here in this point. So there's another portion. Add barium chloride. I'm adding barium chloride to it. When we add barium chloride to it, by adding barium chloride to it, let's see what we have. We have a white precipitate. This one is more like cloud, or that's precipitate, which is, then we add dilute hydrochloric acid. By adding dilute hydrochloric acid, let's see what we have. Is what it is still insoluble. When we have something like this, what it simply means that when we have white precipitate in a compound with barium chloride, simply means that we are likely to have from our observation, what we have is white precipitate, insoluble in dilute HCl. Now, when we have an observation like this, what the white precipitate is telling us here is that we are likely to have triazocarbonate 4 ion, or we have also triazo sulfates 4 ion, or what? Another one is tetraazo sulfate 6 ion. Now, the action in acid, dilute hydrochloric acid now, which is insoluble in dilute hydrochloric acid, confirms the presence of what? Tetraazo sulfate 6 ion, confirmed. Now, these other ones confirmed. These two will give you soluble. They will be soluble. This one will dissolve to liberate carbon 4. This one will liberate sulfur 4. But then with this one, nothing. It will have the hydrochloric acid will not have any effect on it. So that's why that will be the last this thing test. So thank you so much. Actually, I almost missed this one. But then thank God I just remember I'm trying to arrange things. So thank you so much. I want to thank you once again because you have always been there. All right, thank you so much. There is brownish, reddish, brown, precipitate, So what is telling us here is that what would have reducing sugar, confirm, or you can also say glucose. Confirm, because glucose is the commonest reducing sugar that is readily available. So this is what we have, and actually like I said, I'm going to be showing you this at the end of this class. For getting to this point, what we have here, the mixture of the salt is a mixture of C is a mixture of copper sulphate, copper sulphate, tetrasulfate, copper tetrasulfate 6, and the what? Glucose. Glucose, and in the mixture in the ratio of 1:1. So all these things we have done here is all the tests in identifying what? Copper and glucose. So now another thing you should note here is that the Fehling solution is no other thing. For example, Fehling solution A is just a solution that one of the components is what? Copper sulfate. Why the Fehling solution B, one of the components also is what? Sodium hydroxide. So that's why when you mix it, that is why when we heat the mixture of sodium hydroxide and the copper sulfate and sugar, you notice the coloration there. That's because this is the major component of what? Copper sulfate and sodium hydroxide meeting up with sugar. Glucose will always react in that form, giving you reddish brown precipitate, which confirm that there's something there, which is what? Glucose. Glucose that will always reduce what? Well, that will reduce the sugar, the copper 2 to what? Copper 1. So this is the same thing. This is the same process that we experience whenever we use Fehling solution A and B in any reaction. That means copper sulfate and sodium coming together in the presence of sugar to give you that kind of reaction. So there's another this thing, even though the reagents are not given there, I would just want to give you another thing, just that one of the components are not here for me to do the experiment and show you. Now, another thing you should also notice that this compound, when you heat a solid sample of this glucose and copper copper 2 tetrasulfate 6, one thing you should observe is that these salts, they will decompose. You will have a black residue. Under the decomposition, when they decompose, they will release a gas, liberate a gas that will turn blue litmus paper red and bleaches it. This same gas will turn acidified potassium permanganate colorless and potassium dichromate green. Acidified potassium dichromate green. That means what we have there should be what? Ion, should be sulfate for 4. Because in the process, let's go to the reaction. When copper is heated, it will give us copper 2 oxide and what? Sulfur 6 oxide. This sulfur 6 oxide will react with carbon deposited as a result of the composition of glucose to give us what will form that, give us that effect. This is sulfur 4 oxide. Just know this, just in case if anything happen along the way, they say you should give the compound the solid sample of the mixture. Not that that's what you're likely to get. Thank you for coming this far. Thank you. And if you have any question, please leave it in the comment section. Make sure you like, share, tell your friends about us. Thank you.